So state a positive and negative coterminal angle for 7 pi over 6. I would still draw 7 pi over 6. I know that's not part of the instructions, but just to get a visual, even just what quadrant is it in will help. So what quadrant is 7/6 in? Quadrant 3. Okay, so it looks like this. Again, that wasn't part of the directions, so if you didn't do that, fine. I don't know. I think the visual helps me. So if you're going to go backwards, that's like you go that way, I'll go this way. We'll meet on the other side. How far backwards, like negatively, do you go to hit the same spot? -5/6. Good. And I'm kind of hoping you're making that leap if I give you one that's on the unit circle that you can figure it out. Okay. But if you didn't just know that, what is the whole way around? 12/6, 2 pi, and you could just add or subtract, which is actually what I'm going to do to get the positive one. So the positive one, you go 7/6, and then you add on one more full circle. So 7/6 plus 12/6 would be 19/6. All right, just listening to you, like that sounded like that was okay. Okay, good. Radians is just knowing how to deal with fractions, getting a common denominator and all that. All right, this one I actually view as harder because you have to sort of like do math. I would still draw it. What quadrant is -95 going to be in? It'll be barely 3, right? Like just barely past the 90 degrees. Because if we went forwards, it would be in 2, but backwards, it's going to be in 3. All right, so the positive one, if we go this way, how can I get that amount? Like the part that I dotted, like what is the whole way around? 360. If you take your 360 minus 95, let's see, can we do this without a calculator? 265. All right, so 265 is our positive one. To get a negative one, follow me here when I point this. We're going to go -95 and then -360 again. Okay, so what I'm going to do is I'm going to do 360 plus 95, but then I'll just make it negative to show I went backwards. So if you add those together, 455, so I'm going to say -455 degrees. My suggestion is still draw the angle, like draw these, because that helps so much. Did I add wrong? I think I'm good. All right, 3 and 4 is name the quadrants. All right, let me go ahead and write this off to the side. What's positive in quadrant 1? Everything, all of them. What's positive in quadrant 2? Sine, and so also cosecant, like the reciprocals go together. Positive in quadrant 3, tangent and cotangent, and then cosine and secant are positive in quadrant 4. So that's where they're positive. So this is the quadrant game. And what quadrant is sine negative, but secant is positive? So basically you're just looking for where secant is positive. So what quadrant is that in? Quadrant 4, good. All right, in what quadrant is sine positive, but cotangent is negative? So where is sine positive? 2, so quadrant 2. If you didn't get it, then make sure you fix it. All right, what is your reference angle for 135? It doesn't say to draw it, but I still would. I think the visual helps a lot. What quadrant is 135 in? Quadrant 2. And here I'll color code. I know it won't show up real great on here, but your reference angle is with which axis? X-axis. So this is your reference angle. So what would be your reference angle for the 135? 45 degrees. Same thing for 2/3. What quadrant is 2/3 in? Second, good, it would be right here. And so what is your reference angle? It would be this amount, pi/3. The radians are nice because the denominator just matches. Like if this is thirds, it's going to be pi/3. Hanging in there so far? Okay. I see a lot of you not really writing much. That means you already had it. That's good. Okay. All right, now first we're going to figure out what quadrant we're in. It says cosine is negative, tangent is positive. So basically just which quadrant is tangent positive in? Let me show you this backing up. Where's tangent positive? 3. All right, so our triangle is going to be in quadrant 3. So draw yourself a triangle in quadrant 3. And then we just need to get all the like puzzle pieces in the right spot. Tangent is opposite over adjacent. So the 12 is the opposite, 5 is the adjacent. Here's the thing though. We're in the third quadrant. So they're both negative. I realize this came out to be positive, but that's because negatives cancel out. They're both negative. And then what is the hypotenuse? You could either look at what it says here, or that's one of your locker combination ones, 5, 12, 13. The hypotenuse is not ever negative. I'm going to say it again. The hypotenuse is not ever negative. That is always positive. That's sort of like by definition, right? That's your like work. Then you answer the question. It's asking for sine. Sine is opposite over hypotenuse. So using this picture, what is opposite over hypotenuse? Good. Negative 12 over 13. That's it. Sometimes I ask you for all 6. This time I just asked you for one of them. I think, and easy and difficult is always an opinion thing. I think this is the hardest question on here. And this is why. You have to view it as negative 5 over 1. It has to be a ratio because you're doing opposite over adjacent or adjacent over hypotenuse or opposite over hypotenuse, you know, whatever it is. But it has to be a ratio. So it has to be over 1. The kind of good thing is you're told what quadrant it's in. That's like half the battle right there. So we're in quadrant 3. So here's our triangle. And I'm going to ignore the negative for a second. I'm going to put the 5 and the 1 in there, and then I'll see which one gets the negative. Now it says cosecant. Sine is opposite over hypotenuse. So cosecant is hypotenuse over opposite. So I'm going to put the 5 where the hypotenuse goes, 1 where the opposite goes. So 5 goes there, 1 goes there. Which one of those gets the negative 1? Now, this one was one of those little locker combinations. This one's not. How can I get this other side? You would have to do Pythagorean theorem. So a squared plus negative 1 squared equals 5 squared. If you already had this from last time and you're not writing down, that's totally cool. It's weird that like a bunch of you are just sitting there staring at me. You understand I'm going to hand you a test, right? Okay, cool. So I want to make sure we're good. That's why I'm going over all this. All right, so this would be a squared plus 1 equals, bless you, 25. Bless you. A squared equals 24. Is that going to split? Like, do I have to split that up? 24. Yeah. Yes. What will that split into? Yep. 4 times 6. And so it will be 2 square root of 6, except that it's negative. Why is it negative? Third quadrant. Bless you. Are you okay? Okay. All right. So we got all that. Then we're going to answer the question. Cotangent. Well, first let's do tangent. Tangent would be opposite over adjacent. So cotangent is adjacent over opposite. Just flip it over. So using this picture, what is adjacent over opposite? Yeah, it's negative 2 square root of 6 over negative 1, which would just be 2 square root of 6. So you have to work to get the other side of the triangle. That's actually where the bulk of the work is, and then you answer the question. All right, these are your conversions. 340 degrees, how would I turn that into radians? What do you multiply by for radians? Pi over 180. And we can kind of breathe a sigh of relief because it ended with a 0. That's always nice when that happens. The zeros cancel out. You have 34 pi over 18, and you have to reduce that further. So they'll both divide by 2. So 17 pi over 9. Cool. The hardest part is fractions. It's really just fractions. And then this, we're going to do the other way around. 5 pi over 12. I'm going to multiply by 180 over pi. The pi's cancel out. Now you can do 5 times 180 if you want, but what did I tell you would be a better way to go about it? Do 180 divided by 12. If you divide first, it keeps the number smaller. So this is going to be a little side problem. If you can do it in your head, that's cool, but you got to get through it somehow, however it happens in your brain. 12 goes into 18 once. Bring down the 0. 12 goes into 60 5 times. So this would be 5 times, like the 5 just kind of stayed. 5 times 15, is it 75 degrees? Cool. And then these last 2 are the little formulas that we had. Your angle needs to be in radians. So this one's good. I gave it to you in radians. This one, you need to turn the 40 degrees into radians. So exactly like you did with number 9. The zeros are gonna cancel. You have 4 pi over 18. And what's that gonna reduce to? Yeah, 2 pi over 9. Okay, so cool, we got that converted. What's your formula for arc length? R, you literally just multiply the two things together. It's R times theta. So it would be 6 times 2 pi over 9. Now, if it benefits you to put the 6 over 1, that does help a lot of people. You just multiply the numerators, multiply the denominators. So 6 times 2 would be 12. 1 times 9 is 9. And then that reduces 4/3. And I think it was meters, right? This one, again, I gave it to you in radians, so you don't have to convert it. You just have to know the formula. It's 1/2 r squared, which our r is 4, and then times theta. 4 squared. 16, and then half of that is 8. So we have 8 times 3 pi over 4. And same thing, if it benefits you to put the 8 over 1, you multiply the numerators, multiply the denominators. So 8 times 3, 24 pi over 4, which would be 6 pi. Units for that one, yards squared, because it's 2-dimensional. $13, $14, $15, you're going to decide what quadrant you're in. If you get stuck, pick a quadrant. There's only 4 to choose from, okay? And then like fill in your triangle, and I think I have you listing out all 6 of them for these. Even if I only ask you for 1 or 2, a lot of people will still list out all 6 because sometimes it's easier that way. All right, so this says cotangent's positive, cosine's negative. Let me flip it back over. Where is cotangent positive? Third. Okay, you're going to draw a triangle in quadrant 3. Now, tangent is opposite over adjacent. So cotangent is adjacent over opposite. If you want to label, I'm writing it because I'm going to post this on Schoology and then you can all see it. But 5 is the adjacent, 2 is the opposite, except they're both negative. Good. And then how do you get the other side? Pythagorean theorem. It'll be -5 squared plus -2 squared equals, I'll call it R because it's usually that's what we call it for this, R squared, A squared, C squared, I don't care, whatever you want to call it, X, doesn't matter. So this will be 25 plus 4. That would be 29. 29 is not going to split. So you're just going to leave it square root of 29. And then we're just going to list out all 6 of these. Do you remember this lesson where we did this and I said you're going to just have to write them out? And I said you're going to be okay. I think on the test, I did one where you do all 6, and then I did one where I just kind of like chose a couple of them. But again, a lot of people will just do all 6 because it's almost easier that way, just to do all 6 of them. So how do you get sine? Sine is what over what? Good, so that would be -2 over square root of 29. And for cosecant, I'm just going to flip that. I'm going to go and write them all out. I realize you're probably like, hey, wait, we need to fix that. I'm just going to write them all out first, and then I'll go back and fix the ones that need to be fixed, like rationalize. Okay, because I know I need to do that. All right, cosine would be what over what? Yeah, adjacent, -5 over square root of 29. And then secant, you would flip that. And then tangent would be -2 over -5, which the negatives would cancel. That would just be 2/5. And then cotangent was given to you in the problem. That's 5/2. Now there's 2 of them I have to go back and rationalize. Which 2 do I have to do more work for? Yeah, sine and cosine. Sine is going to be -2 square root of 29 over 29, which looks way better, doesn't it? And then this one's -5 square root of 29 over 29. But that's my suggestion. Write all 6 of them out and then go back and fix the ones that need fixing. And even if I only ask you for like a couple of them, probably just still do all 6 and then you can fill in the ones you need. Because when you try to just think about them one at a time, it actually gets more difficult in a way. So for 14, the first question is, what quadrant are you in? Can you put the phone on? What quadrant are you in? So what quadrant is the point -6, 3 in? 2. Okay, good. So we're going to draw our triangle in quadrant 2. -6 is the x, 3 is the y. We went left 6, then up 3 to get to that point. And so we're going to do the exact same thing we did in question 13. We're going to do Pythagorean theorem to get the hypotenuse. And then list out all 6 of the trig functions. Oh, I forgot my squared there. So that'll be 9 plus 36. So was that 45? So that is going to split. When you square root that, what will that split into? Yeah, 9 times 5, and then good, 3 square root of 5. Cool. All right, that's actually like the, bless you, like the hardest work there. Like after this, you're just going to list out all 6 of these. And they would be printed on the test, obviously. You're going to be okay. So just write them out, and then we can go back and figure out which ones we need to simplify further, but just go write all the answers to start with. And then you can go back and kind of be like, okay, which ones do I need to reduce here? All right, so sine would be what over what? Look at your triangle. Opposite over hypotenuse would be what over what? Yeah, good. 3 over 3 square root of 5. Cosecant, you're just going to flip that. And again, we'll come back and reduce them. Just get the answers on the paper first. Cosine would be adjacent over hypotenuse. So -6 over 3 square root of 5. And then secant, you just flip it over. And then tangent would be opposite over adjacent. So 3 over -6. So it'd be -6 over 3. I think all of those are going to have to reduce in some capacity. Let's do the easy ones first. Let's do the ones without the square roots in, because those are going to be the easiest ones. What is tangent going to reduce to? Yeah, -1/2. I knew what you meant. And then this will be -2. So what's going to happen for sine is those 3's will cancel. You'll have 1 over square root of 5. And then what's that going to be? Perfect. Square root of 5 over 5. For cosecant, the 3's cancel and you just get square root of 5. For cosine, 6 divided by 3 is 2. It's just negative. So this will be -2 over square root of 5. -2 square root of 5 over 5. I kind of ran out of room. -2 square root of 5 over 5. Sorry, that kind of ran into secant there. I'll erase it and fix it. All right, this one, 3/6 reduces to 1/2. So negative square root of 5 over 2. You don't need the 1 there. I just put it. I don't know why I put a box around that one and none of the other ones here. Let me go ahead and box the rest of them in. So my suggestion is write the answers, then you can go back and fix them. 15 is actually the exact same thing as 14. You just have to come up with the point yourself. This is the equation. It says x has to be what? You can pick any number your heart desires as long as it's bigger than 0. But you want to pick something that is going to give you nice numbers. So what do you want to plug in for x here? 2 will not give us nice. 6 will work, but there's one that's smaller.
3.
How about 3? Let's do 3. Because watch what will happen. If you plug in 3 for x, the 3's cancel. You would get -2 minus y equals 0. You would get -2 minus y equals 0. You'd add over the 2, so you'd have -y equals 2. So y is going to be -2. And that way you can end up with a whole number and not a fraction. Now it's the exact same thing we did here. What quadrant is that point in? Okay, so listen up. I'm going to tell you the same thing I always tell you that I've been saying all year. If you can't get that point, what should you do? Make one up and then do the problem using the point you invented, because then I can give you something for that. The only thing I can't work with you on is if you leave it totally blank. All right. So then we're going to do Pythagorean theorem to get the other side. Do you guys promise me? Because I see a lot of you not writing anything. That makes me so nervous. You have this and you're ready for next, like you promise you. I know, it makes me nervous. Like I just want everyone to do well. All right, so this would be 9 plus 4, square root of 13. And then you would list all these out. I'll do that and post it. It'll be the same exact thing we did there. Okay. Now this is what we're going to practice the rest of the blocks. I don't need to necessarily do all these. I'd like to do one that's a sixth, one that's a fourth, one that's a third, and one that comes out to be the circle. All right. So let's pick one that is a sixth. Do you see a sixth on here?
26.
Number 26. All right. What quadrant? I'm just going to do one of each. What quadrant is 5, 6 in? All right. And I say this every year, and every year somebody doesn't listen to me. I need a labeled triangle. That is the only work I'm asking for. I am not asking for a lot. I will not mark it right if you don't have a labeled triangle. There are so few answer choices. I need to know you didn't just guess. Okay. I need to see the quadrant is correct, and then I need to see the angle. So what's our reference angle for this one? 5 or 6. If that's not there, you will lose credit. What goes across from 5 or 6? Remember, 6 is the little one. Close. The little one is a half. But that means that the other one is. And then we're not in quadrant 1, so something is negative. The x value is negative. That is the work I'm looking for. I'm seriously not asking for a lot. You got to give me that. Okay. Then you answer the question. It says cosine. Cosine is what part of that? X. Cosine's x. Which part is x? Negative square root of 3 over 2. Let's pick one that's a fourth. Do you see a fourth in there? 22. What quadrant? Good. Couldn't even get the whole question out. What's your reference angle? Pi over 4. That means both the sides. Good. And then what's negative since you're not in quadrant 1? Both of them. That's your work. That is the amount of work I am looking for. But that's not a lot of work, right? Like, actually not work. It's just labeling a triangle. All right, then you answer the question. Oh, this one's cosine again. Cosine is x. That's this one. Negative square root of 2 over 2. Then let's do one that's a third. Do you see a third?
Yeah,
20. All right, where is pi over 3? First quadrant, it would just be pi over 3. You should not eat a third of a pie. I recommend against it. That's a lot of pie. Do you get that a third is the big angle? What goes across from the big angle? Square root of 3 over 2. That means this side's a half. Again, it depends on what the radius of the pie is. If you have a pie that's like this big, maybe you could eat a third of it. But is anything negative? No. Good. Now you answer the question. Tangent is y over x, or opposite over adjacent, however you want to think of that. It will be square root of 3 over 2 over a half, which I get that looks awful, but what happens? They cancel. You get square root of 3 over 1, which is just square root of 3. And then let's do one of the ones that's up, down, left, right. Do you see one that's up, down, left, right? 23 is one of those. So draw a circle. Where is pi? Up, down, left, or right? Left. Okay. And that point is negative 1, 0. That's the amount of work I need to see for one of the circular ones. Cosecant means you flip the y value. Sine is y, so you're going to flip y. Now, y is 0. You cannot divide by 0, so it is undefined. So we did one of each. But just real quick, and I'm gonna fill the rest of this out before I take a picture, but is there another one that you're like, hey, that one looks scary for me, can we do that one too? Speak now before we start doing something else.
Yes.
Everyone look at 17. Quick question, can you guys stay focused? We're gonna do one more problem. Pretend it's a positive 11.6. What quadrant would that be? And if you went forwards 11.6? Because you went almost the whole way around. Now just picture going backwards almost the whole way around. It would be quadrant 1. Good. You went backwards almost the whole way. So your angle is pi over 6. That is a little slice. A 6 is a very small slice. So 1/2 goes across from that. Other side is square root of 3 over 2. We're in quadrant 1, so everything's positive. Secant means you're going to flip which one? Cosine, which is x. Good. It would be 2 over square root of 3. You just flip that over. Do not put 1 over square root of 3 over 2. That looks bananas. Just flip it over. And then when you rationalize that, it will be 2 square root of 3 over 3.